welcome to the live stream. Sorry about that, I just had the microphone off. So, for those who haven't been here before, basically I will speak. There is a chat on the YouTube, which will do most of our communication. In the live stream, I want as much participation as possible because it is very hard just to talk to yourself. So please try and talk as much as you can in the chat, answer as many questions as you can, say I don't know if you don't know, etc. Make sure you're using that because it makes a huge difference to me and it makes me stay here longer. Now, the second thing is, if you haven't been here before, we have a break about every hour. So that's another thing to be aware of. So this help session, most people are probably here for assignment help. Now, to ensure that I'm not repeating myself, I'll cover a couple of little things. Firstly, in regards to some of the stuff in the labs, and then I'll get onto the assignment stuff just so that there's the maximum amount of people here when we get onto the assignment stuff. Does that sound good? This is where you type yes. Can you hear me? Cool. Okay. So you can hear me fine. You understand what I'm saying, and you follow along. All right. So the first thing I'm going to look at is in the lab this week. Last week, we did a whole bunch of if statements. So we did if, let's say, x is greater than 0 and x is less than or equal to 4, let's say. And then you did else if x is greater than 4 and x is less than or equal to 8, and so on. Okay. If there's any issues, just let me know, because I am reading the chat, but I think that person worked it out themselves. All right, so in the lab, we had a big if, else if, else if, else if statement. So I want to do an example here, and we're going to look at, let's say, some variable. Let's call the variable a, and a becomes, actually I'll do it lowercase. And probably should open a new layer. So a becomes, let's say, 2 when x is between, let's say, 0 to 4. Becomes 3 when it's between 4 and 6. Between 6 and 8 becomes 4. Between 8 and 10. I'm not using very good notation here just to get it done quickly, but I think you get the point from the lab of what we're doing here. 14, and then one more. 16. So if x is between 0 and 4, we choose 2. If x is between 4 and 6, a becomes 3. If x is between 6 and 8, 4. So this is very similar to what we saw in the lab. However, a lot of students did something that was a little silly, and we didn't point it out because it was part of the optimization part. And I want to point it out because it may help you in understanding what's happening in an if statement and how it executes. So let me get to the right layer. So given what I've got here, if I have if some ands greater than, actually I'll do that the other way around, greater than some value, less than or equal to another value. So I'm just going to copy that, paste that a couple of times, Save us some time. So here we've got 8 cases. So I'll do all 8. 1, 2, 3, 4, 5, 6, 7, 8. Let's merge them layers. Okay. So now we've got a bunch of if statements. We'll have to add the else's and all that as well. So this is kind of what you wrote in the last lab. If this, else if this, else if this, else if this. There is a reason I'm doing 8 as well, and not 6 as in the lab, just to show you the efficiency problem. Okay, so here we've got our big long list, and then we say x, oops, wrong way around. If x is greater than 0 and x is less than 4, then a becomes 2. Assume a is already defined. 3, 4, 5, 6, 7, 8, let's say. So the next thing we've got is we've got 4, 6, 6, 8, 8, 10, 10, 12, 12, 14. Did I end up with 1 too many? 6, 14, 16. Let's do one more. 16, 18. A becomes 9. Okay, so I've got this big if-else case here. And what we'll notice is there is a large amount of comparisons. So when you get to making your code efficient, this here, let's say your number x is 17. These will all need to be executed before we get down here. Now, one thing with the AND, so we know conditional AND, if both are true, then we get a true, okay? Now, if one is false and the other is true, then it's a false. In the way that C executes this, if this one is false, it won't bother checking this one because it already knows that the result is going to be false, if that makes sense. Let me know if it doesn't. Okay, because a false and a true for an AND always results in a false, it won't actually calculate that second one. But we've still got a large amount of comparisons. So when doing this, let's say my number is 17. Let's have a look at this if-else statement. So the first thing that will happen, it will make this comparison. So is x greater than 0? Yes. So that's one comparison. Is x less than or equal to 4? No. So that's another comparison, and we've got the AND. So there's already 3 comparisons. So we've asked if the number is between 0 and 4. So now we know that the number is definitely not in this range. Okay? Let's assume here also that x is positive. Okay? Just for this case. All right. Then we come along here and ask, is x greater than 4? Well, yes. And is x less than or equal to 6? So we've established that x is between here and here, not between here and here. Now, one thing that we'll notice, was it necessary to check this? We already know that x is greater than 4 because it's positive and it's not in this range. In terms of reading left to right, so remember you've got your associativity rules. It will read left to right in this case when it evaluates this. It depends if you use brackets as well, how it interprets it. But in this case, without the brackets, it will actually go from left to right. It's a special thing with most languages. If you look at your table of operator precedence, it will tell you the order in which things are calculated. So it's just one of the questions. Now, here, we know, I'll get the sheet up if you want to have a look. We know here that it is already greater than 4. And it wouldn't matter if I did this left or right. Okay? So this is redundant. So we can just say, is x less than or equal to 6? And it follows that this one's redundant. Because if it's not less than 6, then it has to be greater than 6. If it's not less than 8, then it has to be greater than 8. If it's not less than 10, then it's greater than 10. And so on, and so on, and so on, and so on. So you can see that I've cut the number of comparisons down quite significantly. So now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 10 comparisons there versus how many comparisons did we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we originally had 24, and now we've got 10. And I'm going to show you another trick you can do, which will slightly drop it, but also make this a bit more even. So we dropped it from 24 comparisons down to 10 comparisons. However, we have a minimum of 3 comparisons and a maximum of 10 to get the answer. So there's a big difference between if we enter a 2 versus, not a 2, well, yeah, a 2 or a 17. So when let's say we're doing a number guessing game and you have to guess my number I'm thinking, and I say it's between 0 and 100. I wouldn't start asking, is it between 0 and 10? I'd ask you, is it greater or less than 50? Because I get rid of the most amount of things. So to efficiently tackle this problem, we can do the same thing. So the middle number is 10. So what I can ask first is if x is less than or equal to 10. Now these are going to get a lot bigger. Else. So it means that we've done one comparison to see if it's below here or if it's above here. Inside here now, I can split this in half. So let's say 6. So I can now ask if x is less than or equal to 6. And I've run out of room already. What I might do, let's move down a bit. Oops. Sorry about this. All right. So there's my pen. There's my pen. So if it's less than 6, we do this. Else, we do this. So we've broken this part down. So if it's less than 6, then we just need to check if it's less than 4. So if x is less than or equal to 4, else. Now, if it's less than 4, then a becomes 2, else a becomes 4. Are we following? So we're just basically, if we had a number line, from let's say 0 to 18 in this case, all I'm doing is breaking it up into smaller and smaller chunks and seeing if it's above or below the line until I reach my point. Now you'll notice that to get to any answer, there's only 3 comparisons. Okay, so if I go down here, there's 3 comparisons. If I go down into here, there's 1, 2, 3. If I go down into here, there's going to be another 3. So just something to think about. We're able to reduce our 10 down to 3, from 24 to 3 comparisons. Okay. If you want to check if it's above 0, you'd have to add another comparison, so maybe 4. But still, this is the most efficient way that you'll find to do this. Does that make sense? I'll get the precedence list up while you say yes or no. So just say yes if that makes sense or no. And where are we going? Oh, so the person who just joined, you didn't miss much. We just talked about partitioning if statements and to reduce the number of comparisons from 24 to 3. So just making your code more efficient. All right, I'm just going to try and find something regarding one of the earlier questions. I can find where it is. Okay, so someone asked about the precedence. So this is your precedence list, and you'll see it has the order, so from the left-hand side. Okay. Some have from the right-hand side as well. All right. So you have to be careful. The ones that are from the right aren't your general maths, though. So most of the ones that follow mathematics, or all the ones that follow your normal mathematics, are going to be from the left because they follow the same rules as maths. Okay, so you can always check that list out. You've got that reference there, so keep a hold on it and you can do that. Now, one question that got asked also about this week's lab. Oops, I just broke everything. Yes, that's the assignment. Don't want that. Don't want that. Don't want that. Don't want that. I want that. I've lost the chat. Where did the chat go? Sorry, guys. Too many windows open. There's the chat. So in terms of the question, it's just simplifying how much code we write. It's not just the fact that we're simplifying how much code we write. It's also the fact that you want efficiency, size consideration. So for example, if I was going to sell you some simulation software that simulated, let's say, stress on a bridge. If you told me it took 4 days to simulate versus some competitor that takes 2 minutes, there's a huge difference there. Once you're talking about bridges and stuff like that, you're talking about huge numbers of vertices and variables. So maybe in the millions range of variables. So these things add up. The other thing is size. So are you going to send someone a program that is 1 gig versus a program that's a couple of megabytes? So it's not just shortening up your code, it's actually making it faster and more in considering the size of it. Now, one thing, now I've lost it. This week's lab. So I just wanted to go over something from this week's lab because we didn't get a chance to go over it during the lab. So the people that were here last week in the live stream have probably already seen this, but I'll go over it again because I think it's really a good way to understand bitwise operators. So in this week's lab, if you've done it or if you haven't done it, I gave you these and I kind of just said, don't worry about what they mean, just use them. So I'll just give you a quick example for anyone that hasn't done the lab. Let's say I've got a variable, so int x, and I give it a binary number, let's say 10101010. If you don't understand what a binary number is, because you haven't been to the lab yet, I'll explain it then, unless you want me to explain it now. But for now, I'll just leave it as this. If you want me to explain it, just tell me and we'll go through it. Or you can wait till the lab. But as we've seen before, we can represent our numbers in multiple ways. Yes, this is where you ask your questions. So we have our binary number, and in memory, this is how all numbers are stored. So this could be represented into a character. It could be represented into a decimal number and converted. All your memory in your computer, your RAM, your hard drive, even the chips are in binary. All right. So I might explain the binary thing again. This will make a lot more sense when you get into pointers and we start looking at memory, but it's good to start understanding it now. So on your computer, let's say your RAM, you have a huge number of spots, okay? Each 8 of these, 1, 2, 3, 4, 1, 2, 3, 4, is called a byte. And each single one of these is called a bit. And these things can be either on or off, okay? In electronic sense, they're of a certain voltage. But we don't care about that right now, or at all, unless you're doing electronics. So in the digital world, we call on 1, or binary 1, or Boolean 1, or however you want to say it, or just 1. We know what you're talking about. And off as being 0. So in each of these spots in memory, there can only be a 1 or a 0. And we'll see in later labs how these are arranged in a certain order and how they relate to each other. But for now, you just have a bunch of bytes. So this is another byte between here. And this is our memory. Now, when I create a variable, let's say car A, the computer will look through memory. I'm not going to explain this too much detail because we'll get into this in later labs, but it will find a space that's free, and this is my variable A for now until the program ends. Okay, and so whatever I store in here is A. So for example, if I go car, whoops, A becomes 4, so just ignore that. Actually, I'll do binary first because it'll probably be the easiest one to understand. I can specify exactly what goes in here in binary. So 1, 0, 1, 1, 0, 1, 1, 0. And in memory, it will write 1, 0, 1, 1, 0, 1, 1, 0. So I'm telling you exactly what to write in memory. However, I could also write my number in decimal. So let's do an easy one, so I don't have to think too much. So I'm going to do, actually, I'll do a slightly harder one, just because, and I'll show you a trick you can do with the calculator in a sec. So I'm going to do decimal 75. Now, decimal's a really ugly number system in terms of converting. You're all very used to decimal, but if you start doing a lot of programming, you realize that decimal is actually not a fun system to use. But in here, we can't store a 75. This can only be a 1 or a 0. Okay? Oh, so someone just asked what the 0b means. It means that I'm specifying the number in binary. Because if I write 1, it thinks it's the number 1 rather than the binary. Or if I write 101, it thinks I'm writing 101. If I write 101 with a 0b in front of it, it knows I'm writing the binary equivalent. So I'll show you in a sec what that means. So here I write 75, and in memory, it'll write the binary equivalent. Now we can do this conversion quite easily. So if I go 0, 1, 0, 0, 1, 0, 1, 1, this bit is the 1s, 2s, 4s, 8s, 16ths, 32s, 64s. So if I add 64 plus 8 plus 2 plus 1, I should get 75. Okay? So that's how I go from that conversion. Now, if you're in the last hangout, you would have seen that I talked about a big table of these and which ones you should know and which ones you shouldn't. And we'll cover that when we get to the exam as well. But it's helpful to start learning these now. Another way we could represent this is in hex. So we've looked at base 10, which is the one you're used to. We've looked at base 2, which is binary. Now we're going to look at base 16, which is called hex. And so this counts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, carry, 1, 0, 1, 1, 1, 2, 1, 3. So same as decimal, once we get to 9, we have to carry over because we only have 10 digits. In hex, we have 16. So someone asked, is binary, decimal, hex, and octal are just different way of writing normal numbers? So a normal number is not defined. So a number needs a base, and for you in primary school and high school, you were told base 10. All the maths works in any base. There is some issues with the finite side of things on a computer, but it doesn't matter what base you're using, all the maths works. It's just how we represent the number. A really good question, is there a format specifier to display binary numbers? No, there isn't, but you can write one really, really, really easily. And we might do that as an exercise in one of the help sessions, because it's a good exercise. So to go to hexadecimal, we've got 0x 4b. So this specifies that I'm writing it in hex, and this is the number in hex. And for those that were in the workshop in the help session last week. If we remember, we split these into 4s, and we've got 1 plus 2, so 3 plus 8 is 11 in decimal, which is B in hexadecimal. And here we've got 1s, 2s, 4s, so it's 4. Okay? So the other thing we could do is we could, did I leave that reference sheet open? Please tell me I did. No, I didn't. We just grab an ASCII table. You're not expected to memorize the ASCII table. It's one other thing. So don't try, because it's pointless. Because you realize then you get to Unicode and there's like a billion different characters. So the ASCII table gives us our decimal and hex equivalent, and we also can write our ASCII equivalent. So for example, D is decimal one we had. So we're using 75. So we've got K. So if I put car K here, it would write exactly the same thing in memory. Yes. So the person asking about the conversion, yes. It's to the power n minus. So it's to the power n minus 1, because to the power 0 is 1. All right. So we'll talk about the conversion a bit later. You do not have to do any complex conversions on the exam or anything like that. And in the labs, you can just use a calculator. And for anyone using Windows, this is what I was going to show you. Get the calculator up. For anyone using Windows 10, standard calculator, if you change this to programmer and you type your number in either hex, decimal, octal, or binary. So let's say I want it in decimal, I write 89, and it gives me it in hex, decimal, octal, and binary. If I change to binary, I can write my number in binary. Obviously, it doesn't have all these digits here, as you can see, because I only have 1s and 0s available. If I go to hex, I get all 16 digits. Okay, so we won't be doing anything really long. We'll show you what you need to know. We're not testing you on your maths. There is some conversions. So from hex to binary and binary to hex are the two big ones that you do need to know. But for now, it's not a huge thing. All right, just use a calculator for now, and then we'll go through that a little later. All right, if you're using a Mac, buy a PC or something. All right. So, does that make sense? It is a rather jarring and complex topic to be introduced to, because it's fairly, if you've been using decimal for 20 odd years, it's very interesting to be confronted with unlimited number systems. So if that makes sense, just let me know in the chat. I'll give you a minute. Or if there's something you want me to clarify further. And by 9 o'clock, we'll start going over the assignment stuff. I want to quickly go over this bitwise stuff beforehand, though. So someone said they were confused about task 2. When you get to the lab, we'll explain that in more detail. Task 2 is actually a fairly easy problem compared to some of the problems we've had, but understanding the concept behind it is a little difficult just because it's rather hard to articulate that problem easily. So when you're in the lab, we'll explain it easier, but it's actually probably one of the shortest lab questions. And once you get it, it's quite quick. So I'm going to go on to the next part. So in the lab, you'll see these 3. We won't worry about this one yet. We'll talk about that one in a sec. So we've got setting a bit, clearing a bit, and toggling a bit. So setting a bit means make the bit 1. If it's already a 1, then it just stays a 1. Clearing a bit changes it to a 0. If it's already a 0, it stays a 0. And toggling a bit means if it's a 1, change it to a 0, and if it's a 0, change it to a 1. So I'm just going to do a really quick example. So let's say I've got 2 variables. Let's say int x. Actually, I'll just do 1 variable. 1, 1, 0, 1, 1, 1, 0, 1. Okay. So 1, 2, 3, 4, 1, 2, 3, 4. Cool. All right. So now what I'm going to do is write x. And let's say I want to set this bit here. Now, one thing that you need to get used to very quickly is this is bit 0, this is bit 1, this is bit 2, this is bit 3, this is bit 4, this is bit 5, this is bit 6, and this is bit 7. So make sure you keep that in mind. And when we get to arrays, it's the same thing. And then you'll go use something like MATLAB, which does the alternative convention, which ruins everything. But the smallest bit is 0. Okay. So if I want to change this bit to a 1, I can write a 1 here. Okay. So this is setting a bit. So now my number would be 1, 1, 0, 1, 1, 1, 1, 1. Okay. Oh yeah, and you start from the smallest. Okay. It's the same as decimal. This is the least significant, and this is the most significant. So you should always start from the right-hand side. If I try and set something that's already set, so let's say I try and set bit 2, now it's not going to do anything because it's already set. Yeah, it will actually overwrite it. So it is actually a waste of time doing this because it will actually go and write a 1 over a 1, but it won't affect your variable there. So let's look at clearing a bit. So this is what it looks like at the moment. So we have unshifted and pick a bit you'd like to clear. First person to put a number gets it. Five. Cool. You had to do 5, didn't you? Okay. So if we do 5, the bit is already cleared. So this won't do anything. It'll just override it with the same 1. If we change this to a 4, then this one will become a 0. Okay. Toggling a bit, we have 1, let's choose to toggle bit 4 again. So I'm at this stage at the moment. Remember, the variable changes as we go. And so now we get 1, 1, 0, 1, 1, 1, 1, 1. Okay. So if it was a 0, it becomes a 1. And if it becomes a 1, it becomes a 0. Okay. Does that make sense? Let me know if that makes sense. And then we'll explain how they actually work. Now, one thing you should also be aware of, there is different ways you can do this. This is my notation that I use, but some people will do slightly different things. I think this is the preferable way, though, in most cases. All right, so I'm just going to look at these. I'll look at testing a little bit later. So we've got a couple of new things here. So the first thing is that you'll notice we've got single ands instead of the 2 ampersands as we saw before. We've also got this new thing here, which is the caret symbol. So this here and this here are conditional so conditional and conditional or. Okay, or you may hear the word Boolean, logical. I like conditional because it's based on a condition, but any word will do. So a conditional and basically takes the result of two things and compares them. And if this is true or this is true, remember the definition of true is not 0, and the definition of false is 0. Okay, so it will compare both of these, and if it's 0 and a 0, it becomes a 0. So the and results in a true or false, being a 1 or a 0. However, what we have over here is binary operators, and I'll add another one, and I'll add another one here. Another one we have is conditional not. So if I say not 43, it's basically saying 0, because not, this is true, so it's 0. So if I say not 4 is greater than 3, this is now false, because this part's true, and then we just not it, so now it becomes a 0. Okay. The same thing here, we have a not for binary as well. So the single ones are binary. And we have a binary not, we have a binary and, we have a binary or, and we have a binary XOR. Okay, we don't have a conditional XOR. You can write one if you want, it's quite easy. So let's have a look at the difference between these. So if I have two binary numbers, let's say 0b, 0, 1, 1, 0, 1, 0, 1, 0. And let's say I put it into an if. Let's say I put it into a variable, actually, because it'll be nicer. And I'm going to do it both ways. So I'm going to use the double ampersands here. And this is a condition. So I'll give you 2 seconds. What is the value in X after this? Okay. Have a guess. So have a guess and see what you think. Okay, so I'm surprised no one really got it. So we just talked about conditional and. It compares two things, and it's just checking if it's true or false. Now, if I wrote this instead, which is exactly the same as this, these are both the same thing because I'm just representing it in decimal instead, you'd be able to see that we've got 106, which is a true value, 86 with the true value, so we get left with a 1. So x is 1. The same thing here. We've got anything that's not 0, anything that's not 0, and so we've got a 1 and a true, and a true and a true becomes a 1. Okay? And that's how a conditional works. Okay? It doesn't matter if it's binary, hex, a character. As long as it's not 0, it's considered true. Okay? Binary 0 would just be 0b0 as well. Does that make sense? Remember, you can use these conditions in expressions and assignment. There's nothing stopping you there. It's still calculated the same. And that's why we showed you in the labs that it returns a number, because that number can be stored. Does that make sense to everyone? Just say yes if it does, no if it doesn't. Okay, so I'll just quickly repeat it. So in the labs, I showed an example. It was something like 4 and 1. This is true because they're both not 0. True and true is a true. Same thing here. And true is a 1. So if 1, then do this. We can also store that value. This is not 0, this is not 0. We add them together, we get a 1. We're going to have a break in a sec at 9. So if you want to wait 2 seconds. All right. So now what I'm going to do is get rid of this. Now, this will produce a completely different result because this is a binary AND. Now, the nice way to compare these is to stack them on top of each other, just so that you can see the comparison easier. And what this does, it does pretty much the same as a condition, except for it does it for every single bit. So 0 and 0 is a 0. 1 and 1 is a 1. A 0 and a 1 is a 0. A 1 and a 0 is a 0. A 0 and a 1 is a 0. A 1 and a 0 is a 0. A 1 and a 1 is a 1. So x would become 1 0 0 0 0 1 0. I'm leaving 0 if you want it. So that's a binary AND. So it actually gives you another value out. It doesn't give you a 1 or a 0. It actually calculates the AND for every single bit between the two. So this 0, this 1, this 1, this 1, and so on. I just threw my pen at myself. If I change this now to an OR, we now get 0 or 0, so it's a 0, 1 or 1, we get a 1, 0 or 1, we get a 1. 1 or 0, we get a 1. 0 or 1, we get a 1. 1 or 0, we get a 1, a 1, and a 0. Okay, so we all know what or and do, and we can see that they do something completely different for both sides. Now, this is all good, but let's have a look further at what this does and this does in terms of numerics. So if I say int, let's do another variable so it's nicer. If I say int y is not 46 or 43, y will store 0 because 43 is true, not true is 0. Okay? We'll talk about the assignment after 9. Okay? So this will give back. Okay? If I put not 0 here, it'll give a 1 back. Now, the not here, a lot of people make a lot of mistakes with this. So I'm going to create another variable called, I'm going to do car and then I'll do int to show you the mistake people make. So I'm going to say int y is equal to 0b 1101 1101. And what I'm going to do is create a new variable called z, and I'm going to say not y, binary not. Now, all this will do is go through each of the bits and do a not to them. So it basically just inverts everything. So what z would now have this in it. Okay? So 1 becomes a 0 becomes a 1. Okay? Now, the big mistake people make with this is that, remember car is 1 byte. Int is 4 bytes. Short is 2 bytes. Okay? So let's change these both to shorts. And write what you think Z will have in it. Yeah, so this symbol is binary not. Okay? This is conditional not. This is binary not. Okay, so binary not, binary and, binary or, binary XOR. We haven't looked at XOR yet. Conditional and, conditional or, conditional not. Okay. So what would Z hold in it in this case? We saw the car case. Now let's have a look at the short case. I'm just going to go through it quickly so that we can get onto the assignment soon. And the assignment's peeking through. He wants to get involved, but no assignment. All right. So here, when we write a decimal number, let's say 24. Yes, so Salem's correct. If we write 24, in mathematics, and I add a 0 in front of it, it's still 24. If I add another 0 in front of it, it's still 24. We can do the same with binary. And if we know that short is 2 bytes, and if we times 2 times 8, we get 16, which is 16 bits. Now, I've only specified the first 8 bits, but you've got to remember that there is another 8 zeros in front of this. So if I binary not here to this number, it's going to take this 1, turn it into a 0 to a 1, these 3 to zeros, this one to a 1, this one to a 0, this one to a 0. And then you've got to remember that there is still 8 more zeros in front. So all of these will become 1s. Okay? Does that make sense? Just say yes if it does. Cool. Cool. I'm losing people. Remember Yep, cool. Okay. Anyone that's new to the YouTube that joined late, try and write comments. The more conversation we have, the longer I can stay here to keep my sanity, because it is hard just talking to a blank chat. All right. The last one is the binary XOR. So XOR has the rule that X stands for exclusive. So we saw the OR. So OR has the case that true, 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 false, false, true, and false, false. For true, it is true. For true, false, it is true. For false, true, it is true. And for false, false, it is false. So it's pretty much either of them are true or both of them are true. An exclusive OR takes the case that both true is not considered an OR. It's actually false. So only one of them can be true for an XOR to be true. Okay? So you can redo this in ones and zeros as well, if you prefer. So a 1 and a 1 returns a 0, a 1 and a 0 returns a 1, and a 0 and a 1 returns a 1, and that returns a 0. So that's your XOR. So if we XOR some numbers, let's say 0b, 0, 1, 0b, 1, 0, 1, 0, another couple of numbers there. So 0 and 1 gives a 1, a 1 and a 1 gives a 0 and a 1 gives a 1, and a 1 and a 0 gives a 1. Okay? So that is that. So I've learned quite a few operators. So what are we missing? We're missing bit shifting, I guess. Now there's another operator here that we haven't seen, which is bit shifting. Now this one's quite easy. But a lot of people make a mistake with this as well, in terms of role. So we've got this and this. Basically how these work is you have a variable here, and then you specify how many bits you want to shift. So let's say I have a variable, I'll do it as a car so that you can see the implications of that. And let's say I have 1, 0, 1, 1. Remember, the leading zeros can be omitted. So if I say, let's say car B becomes A shifted 2 places, then B will store in it this shifted 2 places to the left. So B will have in it 1, 0, 1, 1, 0, 0. Okay, because it's moved to the left. It always introduces zeros, and if it gets to the end, you just lose the end. So if I shift, let's say 6 places, we get 0, 0, 0, 0, 0, 0, 1, 1. And this has gone off the end because we know cars only have 8 bits. Okay, so we lost that information from the shift. And if we shift back, it's not going to come back. It's not stored anywhere. And if we shift the other way, same thing. So if I shift the other way, it will just be 0, 0, 0, 0, 0, 0, 1, 0. And you can call them leading zeros. So we lose them 1, 1. Okay? So we're just shifting the bits across. And if they go off the edge, you lose them either way. Okay, so if you shift too far to the left, they go off the edge. If you shift too far to the left, they just fall off. And it will always introduce new zeros, not ones. Okay? Are we happy with that concept? So let's now have a look at setting a bit. So how this works, let's create a variable again. Let's say car A equals 0B 0 0 0 1 1 0 0 1. Okay. And then I go A or equals 1 shifted to this one, so 2. So we have a compound statement here, and you would have seen this already in your list of operators. We can write something like this, which all it means is A equals A plus 2. We can do A times equals 2, which is exactly the same as A times 2. Okay? You can do that with all the operators. If you slash 2, it doesn't have to be 2, it could be any number. A becomes A divided by 2. They're equivalent. Okay? Just one question that we had. So 8 bits is 1 byte. Okay? So we can rewrite this as being a binary OR 1 shifted bit amount of places, which is 2 in this case. So now we can ignore the left-hand side for now, because nothing gets calculated on that side, it's only stored. So this is where the calculation happens. So we have 0, 0, 0, 1, 1, 0, 0, 1, ORed with a 1 shifted 2 places. Okay? So what's in the brackets will happen first. So if I shift a 1 2 places, I get, I'll do all of them just so that it's clear. I get this because it's moved over 2 places. So if I have 0 0 0 0 0 0 0 1 and I move it across 2 places, I get a 1 here. Okay? It's just a bit shift. So now I have 0 0 0 1 1 0 0 1. And the OR there. Now if I OR these together, a 1 and a 0 will produce a 1. A 0 and a 1 will produce a 1. And a 0 and a 0 will produce a 0. So it maintains the same information by using an OR, whilst introducing a new one. If they're both 1s, it will stay a 1. If it's a 0, it will become a 1. Okay? That's how we set. Try the clear and the other stuff yourselves, because I think most people want to go on to the assignment. Unless you want me to go over anything else. Now the testing one, you need to be careful of because it's not actually assigning anything. So here you should really use it in an if statement or store the value and then test it. Is there any more questions about that? All right, so what I might do, have a quick break. So, let's have a 5-minute break. So I can stop talking for 5 minutes. There's lots of practical applications in shifting bits. You already saw one in terms of setting bits, and you saw it in the lab. Now, there is lots and lots of practical applications of bit stuff, but they're kind of very technical to explain. But if you want to have a chat about it, we can talk about it. But I don't want to bore everyone with that. So let's have a quick break. So you grab a drink and etc. And then we'll go over the assignment. All right. All right, let me know if you're back in the chat. I fix this up. Never left. Actually keen. Cool. Everyone seems to be here. All right. So I'm just going to start with a couple of little things I've noticed from the submission so far. Now, a couple of things that I've noticed is people using break and continue. Now, in this assignment, it is actually written in a way that there is actually appropriate and optimal loops to use. And it's actually quite self-explanatory, as if you saw last week's help session, but we'll go over that again. If you're using these, I can tell you you will lose marks in some sections, okay? Because you're not thinking about the problem very well. It may work, but your implementation is poor considering the tools you have, okay? So if you have used these, after we go through this, you'll probably want to go back and get rid of all your break and continue statements and use the appropriate loops. If we can avoid break and continue, it produces better code, okay? So avoid these unless you really need it. Ideally, don't use them at all unless there is some special purpose. I won't go too deep into why, because it starts to get a bit technical, but just for now, know that if you can avoid them, it's a lot better. Okay? So try and use the appropriate loops, because for this assignment, it's pretty much, there is a set type of loop that you should be using if you understand the questions. Okay? All right, so I think the easiest way to go about this is for me to just walk through each question. I mean, each step, and roughly outline what's going on without giving you away too much answers, but just picking up important concepts. You need loops in the solution. If you don't have any loops, then I can tell you you're definitely losing marks, because there's things that won't work without a loop. All right. So the first thing we have is to print your name to the screen. Now, there is actually marks for the formatting of this, so make sure you write your name correctly and that you spell your name correctly. That is really important, because when we run it through our program, it will compare. So make sure your name's spelled right and it's the same as it's spelled on LMS. Don't use a shortened nickname. Okay. The other thing I want to quickly mention, if you have go-to statements, get rid of them completely. We do not want to see that. It's not taught in this subject, and there is a reason behind why we don't teach that. Okay, so I did put a warning on LMS about that as well. Okay. So first things first, print out your name. I'm pretty sure everyone knows how to do that by this stage. The program asks the user which table they would like to create as follows. Once again, we're just printing to the screen. I don't think anyone should have any problem with that. Okay, it's just printing that to the screen. Then the program accepts an integer value. Okay, so you can assume that the user always enters a valid value unless you're doing the bonus task. All right. So we're not going to put in some random letter or some float variable. We are going to always enter a 1 or a 2, and that's it. Okay, unless you're doing the bonus. Or an invalid integer. So let's say 9 or 10. Okay, so we're not going to pull you up if it doesn't work if I enter the letter A. Okay, so you can always assume that they're going to use an integer unless you're doing the bonus. All right, so we know how to accept a value to use scanf to get values from the user. So I'm pretty sure everyone knows how to use scanf by now. So that's all good. If the user does not enter a valid value, the program should print the following. So the following says invalid input, please try again. And then reprints the same thing over again. You'll notice that it could keep looping 100 or I'm not going to give too much help on the bonus because that is a very challenging question. So I'm going to focus on the assignment, not the challenge. So you'll notice that it keeps asking. So we know there is a loop happening here. Okay. What kind of loop would either be a do, while, a while, or a for? Now, a do while is good for something that happens at least once, whereas a while happens 0 or more times. A for loop is more if you know where it's going to end or that it's based on some condition. So we can ignore this one for now because we don't know when it's going to finish. We're just basing off the user's input. So we know that it's going to be either a do while or a while loop here. Okay? The clue here to which one is that we print this at least once. So it's not 0 or more times. It's going to be 1 or more times. So we can get rid of the while loop. We know that it's going to be a do while loop here. Okay? So this part here, we can assume is going to be a do while loop. So it will keep printing this while it's not a valid value. Okay? Once it leaves that loop because you've entered a correct value, then we can check the conditions. So we have for and we have step 7. Okay, so we see this keyword here, if. So I'm just going to loosely write this code. So we've got some printing statement. We've got some kind of do while loop. We've got some printing and scanning going on here for this part. And then after that, if the user enters a 1 we do something, else or else if, depending on how you implemented this. If you use a while loop, you can use it, but you're not understanding the purpose of a do while loop. As I said, a do while one or more times, a while is 0 or more times. In this case, we always wanted to print at least once. So why would we use the while when we've got a more efficient way of doing it? Okay, you can use a while loop. However, you need to think about what's the most appropriate way to do about it if you want the marks. And make sure you justify this in your comments why you chose which one. So we've got this if here. We've got this if here. You can do that however you like. So if they enter a 1, then we print something to the screen, and we need to collect something from the screen. So once again, it's just a print and a scan. Once again, we can assume you won't lose marks if you do a do while or a while loop. You lose marks if you use the wrong one. The problem. Unless you come up with some super efficient way to do it. But considering... So for this problem, the do while in step 3 is the most appropriate way to do it because we do this at least once. Okay, and a do while does some things 1 or more times, where a while loop will do things 0 or more times. So you won't lose marks if you do a do while loop, unless you do it incorrectly or you do something wrong. But you need to justify why you did which one. Okay, both of them will work, but one is better than the other. If you use a double rather than a float, then you're not following the steps. And there is, I'm pretty sure there's marks for using the appropriate types. If it tells you to use a float, then you need to use a float. If it tells you to use a double, then you need to use a double. Okay? Are we on the right page? I might do an example with the do while loop. Let me think. So the do while loop, let's say we have int x, okay, and just int x. And we do something like scanf %d x, and while x is less than 4. Okay, so this problem here is we create an x, it will check the user's input, and if they enter, say, 2, then it will check here and go 2 is less than 4, so it will continue. And it will continue, and it will continue, and it will continue, and it will continue, and it will continue. The alternative way to do the same problem with a while loop would be to have int x, scanf %d x, while x is less than 4, scanf %d / x. So you can see, because we had to ask this user at least once to enter their value, to change it to a while loop, we now have to do the scanf twice. Okay? In the case that we didn't need to ask the user to start off with, so let's say we have another problem. So my problem is called countdown, okay? So I want the user to enter a value. And I want to count down from that value. So I create a while loop, and while x is greater than or equal to 0. Okay? This would be a suitable case for using a while rather than a do while, because what do I want? X equals x minus 1. Now you can use the decrement operator if you know how to use that instead. So in this case, if the user enters something negative, then we don't want to start printing anything. If they enter something positive, then we go into the while loop and we print it out. So for this problem, the while is more efficient. For the other problem I showed you, the do while was more efficient. It depends on the problem. Neither are more efficient or less efficient. It needs to be suitable for the problem. In this case, there is one that is better than the other. Both will work, and in some other problem, it'll be the other way around. Does that make sense? And this 1 or more or 0 or more is the key thing here. If the bonus doesn't work, get rid of it. There's no half marks for the bonus. There's only it works or it doesn't. So if it doesn't work, just get rid of it. It has to work fully to get marks for the bonus. Every single case has to pass. Okay? So you need to choose the most appropriate one for this. Do we need to do this 1 or more times, or do we need to do this 0 or more times? In this case, how many times do we have to print this? At least once. So it's going to be 1 or more. In some other problems, we may not have to print this, and this one may be better. Okay? All right. I hope that makes sense. All right. So we then print and scan, and then we print and scan. These are very similar. Once again, you can assume that the starting value will be smaller than the ending value. So here, you can just assume that everything's all right. Do the bonus for this later. Make sure it works first. Then we've got the program should ask the user for a value between 0 and 99. Please enter. So another print and scan. So these are fairly mundane and similar. Okay, so we've got a bunch of prints and scans here, times 3. And exactly the same here, except for we've got floats. Okay. Once again, you can assume that it's valid. Okay, we're not going to do anything sneaky here. All right. Then you'll notice that we have B for 9 and B for 6. So remember, all of this stuff is related to 4, and all this stuff is related to 9. So we can stay within these same if statements if we like. Well, we kind of have to. Okay, so you've got your Pinton scan times 3, which is step 4, 5, 6, 8, and 7, 8, 9A for these. All right. Now we look at B. So 6B goes here, and 9B is going to go somewhere here. Okay, remember, make it logical. All right. So all the stuff, if they enter a 1, is going to happen here, else we do all the stuff relating to 2, which is the other conversion. All right. The program prints a table where the first column is degrees Celsius. The value starts at the starting value and is incremented by the step value, while the value is less than or equal to the ending value. This is a huge, huge clue. And even more of a clue is hint for loop. Okay, it tells you pretty much exactly what to write there. The second column is degrees Fahrenheit calculated by converting blah, blah, blah. All right, then you've got a whole heap of formatting stuff. We can go through the formatting stuff a little later. Okay, that's quite easy. So this big chunk here is just a bit of maths and using a for loop. Now, why do we use a for loop? So let's have a look at a for loop, and let's have a look why we should use a for loop. Okay, if you've used another loop, you'll see why this is so suitable for this problem. No, there is no bonus for checking the step size. I don't think. You have to check yourself. I don't have that open. Okay, I can't access. Okay. Yeah, you do have to check the step size for the bonus. All right, so let's have a look at a for loop and why it is so pretty. Okay, so variable called x, and I'm going to write for x is assigned 0, x less than 4, x plus plus. Now, if you haven't seen the x plus plus before, all that is x equals x plus 1. Okay. There is another version of this which is plus plus x. We'll talk about that later. Okay, but for now, just you can look at that and just imagine it's this. It's not really, but in this case, we can treat it as it is. All right. So let's have a look at how a for loop works. So we have the initial, we have the condition, and we have the update. Other people use other namings for these, but I just use that because I think it makes the most sense. So if x is 0, which is the initial, we then have our condition, which is x less than 4, so that's our condition. In here we have some code, okay? we have some code. And then we have our update, which is last. Okay. And this is if it's true. And if it's false, it goes down to other code. Okay. So other code and some code could be any code that you write in there. Okay. And that's if it's false. All right. So in this case, my sum code is going to be something very basic. Let's say printf SMP x plus 1. Okay. For the person asking about the bonus for checking the step size, yes, read the bonus information. If you're doing the bonus, you need to read it yourself. Okay? Bonus is above and beyond. All right. So this is my for loop here. Okay? So in this case, we have our variable x. I'm just going to put it here. So we have x. You'll start seeing these diagrams soon. I did it wrong anyway. Okay, so we've got variable int, which is a type int. It's variable name x. And at the moment, at the start here, it has who knows what in it. Okay? We then get to the for loop. So the first part of the for loop, it sets x to 0. So it does this part first. So we get 0. It then checks, is x less than 4? Yes, it is. So it's true. So it will go to the sum code part. So it will print x plus 1, which is 0 plus 1. So it'll print 1 to the screen. It's then done that code. So it'll follow back up here and do the x plus 1. So now x has in it 1. Okay. It then checks, is x less than 4? Yes. So it'll print out x plus 1, which is 2. So we've done the sum code, we go back up, we do plus plus, so now x equals 2. Is x less than 4? Yes. So we print out x plus 2, which is 3. We've done our sum code, we go back up, we add 1, so we get 3. Is 3 less than 4? Yes. So we go back down, we print out 3 plus 1, which is 4. We then go back up here. We now have 4 in here. And is 4 less than 4? No. So we leave the for loop and go to our other code down here. Okay? Now, I don't know why I'm rubbing that out. What you'll notice here is that a for loop follows so let's do another example. So I'm going to change this to 2. I'm going to make it continue while x is less than 6. And each time it goes around, x gets added by 2. Okay? So in this case, we have x becomes 2, x is less than 6, and x becomes x plus 2. Okay? I probably should have left that there. And I'll just print the value out this time, because you'll soon go, oh dear, this explains the world to me and this assignment. So in this case, we have our x variable again, which is an int. At the start, we don't know what's in there, okay, because we're currently here. We then get to the for loop. The first thing that happens in the for loop, it sets x to a 2. We then check, is 2 less than 6? Yes. We then go down into the sum code and do the sum code. So it doesn't do this yet. Make sure to draw down this flow diagram. It should be in your lectures. And we print out 2. We then update this by adding 2 plus 2, and we get 4. So is 4 less than 6? Yes. So we print out 4, and we go back up, and we add 2, so now there's 6 in there. Is 6 less than 6? No, so we legs it. What if we've already declared an x value? What do you mean? Can you give me an example of what you mean? X is already declared. It's here. It's declared. So give me an example of what you're trying to ask. Because X is already declared. Just wait for. Okay, so if we declared X to a value earlier, let's say X, so if we give X a value earlier, so let's say I initialize it. So let's say I initialize it to 6. X becomes 8. Okay. And then somewhere else in the code down here, I say X becomes 10. Remember, this is a variable. It can change all over the place. So here, X equals 6 becomes 6. Then the next line, go away. Then the next line happens and changes this to an 8. Then we get here, and the for loop starts, and we overwrite that 8 with a 2. And then we do this whole thing, so it goes a 4, and then to a 6. And then this will exit, and then it'll overwrite, and it'll become a 10. Okay? So we can change X wherever. However, when we get to this for loop, it'll do this first. We can, if we really want. However, we shouldn't have to, especially in an assignment. We could just leave this blank, and X will have 8 when it starts, and this will do nothing when it starts, because that was the last time X was assigned. No, you don't have to initialize, well, not initialize it, assign it. So a lot of people get confused about initialization and assignment. Initialization just means that you give it a value when you first create it. So car A becomes 4. That's initialization. And it's also assignment. And it's also declaration. The reason we say assignment is initialization because it implies that we're using assignment and declaration at the same time. If we just say A becomes 4, it's just assignment. Initialization just means we're assigning and declaring at the same time. If we just have car A, then we're just declaring. Okay, so a good way to look at this, car A is declaring. Car A becomes 4 is initialization, which is declaring and assignment. And then we have assignment, which is just A becomes something. Okay, so that's the difference. So initialization just means that you do all of this in one at the start. Okay. Anyways, the other thing we can do to further the question that was asked, let's say I've got scanf, sent D, A, and I ask the user where to start this loop. So I create another variable x, and before that I've got a variable a. So I can say x becomes a at the start. So if the user enters a 0, then the loop starts at 0. If the user enters a 2, then the loop starts at a 2. If I ask them for another variable, let's say a b, we could do that. If I ask them for another variable, I could do something like this, if you catch my drift of where I'm going. So here we have our starting value. Here we have our ending value. And here, as you noticed before, if this was +1, we step by 1s. If it was +2, we step by 2s. So this would be our stepping value. And this is why this problem is suited for a for loop, because a for loop is made to solve this problem. Okay, you can do it with a while loop, you can do it with a do while loop. However, it's going to be a lot slower and a lot more painful, because you pretty much do the whole thing. Does that make sense? Now, when it gets to using the floats and writing an equation here in this part, it may be a little bit more difficult than just plussing a value, but it's still not that difficult. Okay? Does that make sense to everyone? The for loop and how it relates to the problem. Most people will have problems here, but these two are usually very easy. I need more yeses. That's good. Cool. So now we know why we should use a for loop today. So you can see the value starts at the starting value, which is going to be in the initial, increments by the step value. So increments by the step value. And the value is less than or equal. So remember that less than is this, less than or equal is this. Greater than is this, greater than or equal is this. Okay? Now, inside this, we're just doing some printfs. Okay? We can either, there's a couple of ways of going about this. We can either use this variable to calculate certain things. We can create another variable to hold the answer to certain things, or you can do all your calculations in the printf. A lot of people have done this very differently. I'll leave that up to you, how you want to go about that. If you find it easier to create a bunch of variables, then you can do that. If you find it easier just doing all your calculations in the printf, that's fine too. Okay. Then we can see that the what happened here? Okay, some text has disappeared there. That might have been when I copied it. Might not actually be this. I hope it's not this. I'm not sure. Oh, cool. Okay, so I've just copied it wrong when I put it in here. That's okay. I thought I fucked up. All right, so we can see here that it's pretty much the same thing, except for we're going to use floats in the second one. Okay? There isn't too much different given that. Now, one other thing, depending on your solution and how you go about this, you don't actually have to put the stepping value here. And you don't actually have to put the starting or ending value here. There are multiple ways to do this, but this is just a hint if you want to do it this way. Okay? If you've got another way of doing it, you can do the for loop still very efficiently without actually using these values here and using other values. But I'll leave that up to you if you've got a different solution. So don't feel you're wrong if you're doing for loop and you're starting from 0 to a certain value. Okay, there is a way of doing that, and that's how I've done my solution. But I think this is the easiest way. I think it's the way most people do. All right, so we're pretty good. I don't think there's anything after 10 minutes in the program. So now we just got this stuff here. So there is an empty line after the user's input. We've all seen new line, so we know how to make an empty line. Okay. If you want to make an empty line, remember you may need to put 2 new lines to go to the next line. Now, this was covered in the first lecture, I think, one of some maths lectures. But let me grab something else. Week 2. Reference. So in the reference sheet, if we go here and it says formatting, so what do I do? Let's just expand that. So in your reference sheet, you have something that looks like this. Okay. So we've all seen over and over the number of decimal places, but we haven't looked at this width very much in the labs. However, in the assignment, it is quite important. Okay, so it asks for a specific width. I'm just going to give you an example of something else. So let's say I've got printf for, what am I doing? Percent for D, and I print 21. Okay, so this 4 says the minimum number of characters that are to be, number of characters to display on the screen when I print out this. Okay, so here I don't even have a variable, I'm just printing a constant, which is kind of redundant because I could just write 21 here, but it's a good example anyway. So this must take up 4 spaces. Okay. So, and it's right justified naturally. Okay. So let's have a look what that means. Just want to grab something else. Like this. No, I don't need that. All right. So on the screen, we have a bunch of spaces to put characters. However, the screen isn't gritty, it just prints, as you know. So this will print space, space 21, because it's saying that at minimum, I must print 4 characters. And so it'll fill the blank space with spaces. Okay, so this is what the width does. All right, I'll give you another example. So let's say I have percent 5.3 and F, and then I print to the screen 1.24. Yeah, that'll do. So this must be at minimum 5 with 3 decimal places. So with 3 decimal places, I have 1240, and this is already 1, 2, 3, 4, 5 characters. So that's fine. It's not going to add any space. If I change this to a 6, then it would be blank space 1.240. If I change this to a 7, it would be blank blank 1.240. If I change this to, let's say, a 2, it's going to print 1.240 because it is the minimum. Okay, so the minimum number of characters displayed. If there's more than that, it will display them all. Okay, so if I say 2 here, obviously this is 5 characters long, so it's going to print out more than 2. One other thing is these flags. Okay, so let's have a look at the pads with leading zeros, because that's kind of a nice one. So if I write, let's go make this a little bigger. So we'll start with this one, the pad with leading zeros. So if I write something like %0 6D, and then I write my number as 41. What this is going to do is take up a minimum of 6 places and then use the flag 0, which says pad with leading zeros. So instead of spaces, these 4 spaces this time, instead it's going to have 4 zeros and then 41. Okay? Another flag is the minus, and this is left justify. So if I put minus 4D, we're going to have 41 space space. Okay, because it's justifying it to the left instead. Okay. If I say always display sign, so if I put a plus here, it's going to print plus 41. And if it's a negative number, it will print negative 41. Okay? And the space will display a space if no sign. So what that means is that if it's not negative, it will just have a space in front of it. Okay, and I think that covers pretty much what the assignment in terms of this stuff. Now let's have a look at the report. So, two things with the report, or three things, sorry. The report is there just to show that you understand what you're writing. If your report shows that you had no clue what you were writing, then you have no clue what you're writing. It says produce a report of 300 plus or minus 150 words. If you go a little bit above that, that's fine. Okay? A lot of people struggled to keep this word limit and wrote about 500 to 600. That's fine. I don't really care. If it starts getting ridiculous, then we'll start caring. But it's fine. If you can write in 150 words, I'd be very surprised. Okay? That'd be very difficult. So basically, explain your code and why you chose your particular implementation, and then have some keywords in there. If you go down to the marking guide, now for everything you do, go through this whole marking guide because this is how you're getting marked. Okay? And I can see mistakes in there. I'll fix that up. It doesn't really change much. So make sure you check the marking guide for the report. So you'll notice that there is 4 points for spelling and grammar. There is 10 points for justification. So if you tell me I used a for loop, there's no justification there. Why did you use a for loop? Why did you choose to use a do while loop instead of a while loop? Why did you choose to, I don't know, introduce a new variable, etc.? So make sure there's justification because it's worth quite a lot, and that you explain your code. Okay, these are the three things that you're getting marked on for the report. Also, make sure your name's on the report. Now, to help you out, if you go to LMS, there's this report help here. It's not very long, but what you need to do is make sure you write the purpose of the code, how you did it, the results, if it worked or not, and justification and discussion. For example, why was casting used or why was a for loop used? And that's basically how you should write your report. I'm going to have a quick break. Get your questions together. And we can go through some more questions. I might start having a look at next week's content. I should use that layout. That's cool. I'm going to do zoom in. No, don't. If you do the bonus question, you don't need to explain it, but it will be rigorously tested, and don't forget all your code is checked against last year's work and this year's work. All right. I'll be back in 5 minutes. Start putting your questions together, and we'll start having a look at some other stuff soon as well. Mute. All right, I'm back. I can get rid of that. Let's hide it. It's probably easier. All right, so first things first, someone asked about the report. If they should put their comments into the reports. No. So you're all either IT specialists, engineers, or scientists. So it needs to be a scientific report. So it should have a purpose, it should have a method, justification, and discussion. And it's just going to be very short. Okay? So don't just copy your comments into the report. It may be very similar to your comments, but it just needs to be outlined like a report. Okay? You need to use proper sentences. For comments, we do not care really about your grammar or things like that, unless it's nonsensical and we can't read it, because they're just comments. And as long as we can follow along, it's fine. But for the report, we do care about spelling, grammar, justification, etc. All right. So I think what I want to do now, I think, how do we feel about the assignment now? Have I covered everything from the assignment that is enough to get you through it? Or is there any other questions about the assignment? So the big takeaways, go away. The big takeaways in the assignment are: one, don't use continue, break, or go to, especially go to. Two, the choice of do while versus while is important, but they both will work. Three is there's lots of printfs and scanfs that follow. Four is that the problem is suited for a for loop. If you haven't used a for loop, then you've got huge amounts of inefficiency, and so you're probably going to lose quite a number of marks. If you haven't used the loop at all, then your program shouldn't really operate as expected, and it probably won't work as it should, because we need to loop in this case. Because we can have cases here that I can infinitely enter the wrong value. You cannot handle that without a loop. Okay? A loop or a go-to, but as I said, do not use go-to, because it demonstrates that you haven't followed what the lectures are going on about. And we'll see why that's bad later. Okay, so we saw the for loop. We saw the things about width in your formatting. We saw that the report needs to explain, justify, and spelling and grammar are the three things we're looking for in the marking guide. The seventh thing has to do with the bonus. The bonus has to work 100% to get any marks for the bonus. So if it works 99.99999% of the time, don't bother including it. It has to work 100% of the time. And the way you check that is using the test cases I've given you on LMS, because these are the test cases that we are going to give you, we are going to test it against. So it has to work for all of these. So REF 3.3, 2.2, 1.1, 6FGF, Hello Space World, 4.565. It has to work and give an invalid input for all of these. Okay, and don't hard code that in, obviously. And then same for these, it has to work for all of these cases. Okay, these are the ones we're going to test it against. If it doesn't work for one of these, don't bother putting the bonus in the assignment. Okay, because as I said, there are no partial marks. Okay, and it may cause issues elsewhere. Okay, so they're the main things. We went through every step by step. If you're late, so you can go back and watch it later if you like. And now we're going to look at cats and dogs and fish and things like that. All right. So, is there anything more you want to go over about the assignment, or do you want to start looking at next week? So you're prepared for next week.
Is there any more questions about the assignment? Give me a couple minutes.
It'll be pretty obvious to us if you've done the bonus, but if you want to indicate it, it's nice for us to know. It doesn't hurt. You can put a comment in there saying that you did the bonuses, but if you did the bonus, it should be pretty obvious because it's not a simple solution. And I will go through the solution for the bonus after the assignment's been submitted, because it is actually quite clever how you go about it with a problem like this. And it's a problem that comes up quite often. To drop out, it's quite easy. I don't know about the other thing. Dropping out is purely through student online, but I don't recommend you do that because I think you can learn a lot from this subject. But the other one, I have no clue about. I have no experience. Should a program end after presenting a table? Yes, it should. So it doesn't loop continuously after. It's not like the lab we did today where it's just prints and then it asks, do you want to go again? Do you want to go again? It just says end the program. So let's see if I can get it up. So this is my implementation. You can't see the code, but let's say 1, starting temperature 20, ending temperature, let's go 50, step size is 50. Let's say the step size is 2. So print out the table, and it's done. Okay. So if your final output keeps coming out as a single number, so this is something that you should be doing in your labs, is trying to print out all your variables as you go. It's the best way to find out what's going wrong. So let's say I've got a bit of code. Int x equals 4, y equals 6. We've got I, we've got 4, I equals 4. I less than 18 I plus. I'm just making shit up here. So, let's say okay, so here's an example. It's kind of pointless, but it's just some random bit of code. So here you can see there's this whole heap of numbers and stuff happening. So to debug this, I can sit down with a pen and paper and follow this along and see what I expect the values to be. And what I can do in here is print my variables out. So if I've got assignment, I'm pretty safe in saying that I know that y is still a 6 here. However, down here, I have no clue what x is going to be. So I should probably, after I use x here, print out. Actually, I'll do this a little nicer. Print out x is the value. I'll put a new line as well, so it's nice. X. I introduced this variable z. Now, it's only in scope there, so I can't use it anywhere else, but I'll print it anyway. Slash new line. I have this y divided by 2, so I might want to check what that result is. So I can just do y over 2 is... Now, if I want this as a float or an int, depends on the problem. I could write it as both, I suppose, to see what the result would be for both of them. So I could do y over 2, y over 2. And you'll see what I'm doing is I'm checking the variables as I go along. Okay. I can also do something like, does this if statement execute? So I can go printf x is equal to y over 2 is true, and just have that as some text. Because if that prints, then I know I'm going in here and not in here. So adding all these little printf statements allows me to debug my code and my math. Okay? When you do this, just for us, if you're doing this, comment it out and leave it in the code. Okay? Don't leave it in the running code, but leave it as a comment. The reason being is it's good practice to debug, and we want to see who's actually debugging their code. Okay? Now, the other way is to look at the mathematics. So if we go have a look at the assignment sheet, oh, that's not the assignment sheet. That's something I shouldn't. Assignment sheet, we can go have a look at the maths, and we can look at this formula and we can see where the 32 is. And we can see that obviously this is resulting to a 0 if you're constantly getting a 32. And this is resulting to a 0 because of the multiplication. Now, it may have to do with typecasting, because if you've left these both as ints, or it could be something else. So do not forget your casting. This is going to haunt you throughout the subject. Okay, an int divided by an int is an int. So 6 divided by 9 is 1. 0, sorry. Ugh. Too late at night. okay? Because we don't keep the floating point part. So we have to cast at least one of these to a float to get the floating part. If one's already afloat, it's fine. It'll give the right answer. But if one of them's not afloat, then we need to cast. So we can just do float A divided by B. Or we can do A over. Actually, I want to quickly go over an example that I see people do and make a mistake with. So with casting. Anyway, that's a good reminder. So let's say I've got int A is 2, int B is 4, let's say. Yep. And then I do some kind of calculation. Sorry. Then I do some calculation. So I go int C is A plus B divided by A plus B. Okay. That's a bad example because then I'm just going to get, let's do times here. Okay. So in this case, we get in this case, we get an int times an int divided by an int plus an int. So by now we should understand that this would reduce to an int, this would reduce to an int, and we get an int as a result. Now, one thing that I have seen people do is this. Oh, this should be a float because it doesn't matter what we do, it's going to end up as an int otherwise. So we have 2 times 4 divided by 2 plus 4. So we've got 8 over 6. Okay. What are you? Okay, so our answer should be 1.33333, but instead we get a 1 out. Okay, if we do this normally. What do we get out if we do it this way? Do we get the 1.33 as we want, or do we still get a 1? So have a go of that and let me know what you think. The person asking about connecting, if you can put a screenshot in the forum, and I can have a look. So the forum's on LMS. So you've got the discussion forum, just go to student questions and ask a question there. You get a 1. Good. Cool. So you all seem to understand why you get a 1. So it's because the brackets will happen first and then we typecast it. So you have to be really careful about this. There's absolutely 1, 2, 3, 4, 5, 6 different places you can put the typecast and 1 wrong place you can put the typecast. So that's just something I wanted to mention because a lot of people do make that mistake. All right. Let me know when you put your screenshot in the forum as well of what's going wrong. So I'll double check it. All right, so now I want to talk about cats, dogs, fishes, and stuff like this. So with our variables so far, we've talked about a single thing. So we've talked about the variable A. We've talked about, I don't know, a single resistor. And we've talked about another resistor. What's some of the other things we've done? We've talked about area. These are all single things. Okay, so what happens when we have cats and dogs? So if I have dogs, this is a collection. Okay, so my variables currently have been singular, but I want to start looking at plural variables. I don't want to do dog 1, dog 2, dog 3, dog 4. Rather, I want to have a collection of plurals. Can you stop before we look on it? Check what it is. How do you stop before we run it updates and return? Check whether the statement is true or not. The for loop. So the for loop. Sorry, I'm just going to answer this question quickly. It's about the assignment. For loop. This middle section is the condition. Okay, this will always happen at the start and then after the update. Okay, so this is the update, this is the condition, this is the initial. This is the initial, this is the condition, this is the update, and then there's some code here. Okay, so after it updates, it will check the condition. Okay, and that's how it will stop. All right, so let's go back to dogs. So we want a plural variable. Now, this is going to be something that will kind of drive you mad for a little while in the labs, because this is not a simple topic and it's something that will go on for quite a while, because this dynamic and static declarations of things that are plural. And what we call this is what is called as an array. So we have an array of things. Okay. So let's look at our first array. So dogs are better, so we'll use dogs and we'll use their height. Okay. So I want a collection of dog heights. So currently how we would have done this is we would have gone int, dog height 1 equals 4. Dog height 2 is 3. dog height 3 is 7. Okay. However, to do an array, what we do is we say int dog heights, just to give it a more meaningful name to show that it's a collection of things, and we put these square braces. Okay? And in here, we specify the number of things in our collection. We will see dynamic, which is very differently, so don't put a variable in here. So let's say we've got 3 dogs, so we'll put a 3 in there. Okay? So now I have 3 variables. Okay? And we can look at this 2 ways. It doesn't matter which direction you go because it'll make sense either way. But the first dog height is index 0. The second dog height is index 1, and the third dog height is index 2. Okay? And currently they have I don't know in them. Okay? So we can initialize an array, like our variables, by going like this. 8, 2, 1. And what this will do is put an 8 in the first index, a 2 in the second index, and a 1 in the third index. Does that make sense so far? Say yes if it does. Is anyone else still listening? Or are they all given up because I've given their assignment stuff? Alright, I'll keep going for a little bit. I'll post this in the forum. Let's go a little bit forum first. LMS is having massive issues with us. Okay, connected. Can you put another screenshot of showing what you actually entered into Putty? Because everything looks fine. You've got the VPN connected, so just show what you entered into Putty, I guess. All right, so we've now got this initialized collection. So now I can start using this like I would any other variable, except for I need to indicate which one in the collection I'm talking about. So if I wanted to change the first dog height, let's say somehow incredibly got shorter, then I can go dog heights 0 becomes 2, let's say. So this here now becomes a 2. Okay? Remember this starts at 0. Okay? So 0, 1, 2, because we've declared 3. This gets really confusing for some people. So I can change the value of any of these variables. So let's say 1, and I change it to 4. So this becomes a 4. All right. I can also use this on the right-hand side. So I could say dog height 2 is the result of dog heights 0 plus dog heights 1. So it'll overwrite what's there and it'll add 2 plus 4, so we get 6. Does that make sense so far? Just having a look what's in the lab. I do have the lab open. There it is. So yes, it makes sense. Ooh, and we've got functions. Wow. We're going to be learning a lot next week's. All right, so go check out this. Okay, I am confused. To the person that's trying to connect to Buddy, I cannot see anything wrong at all. If anyone else can have a look in the forum and see if you can notice anything wrong, because I can't see anything wrong at all. It all looks right. So if anyone else is there to give a hand, have a look in the forum, because this person's having trouble connecting and I can't see what's wrong. All right, so we've got our dogs and we're able to add them together. We're able to insert values into them, things like that. Now, what comes in really handy with the arrays, they work very neatly with for loops. So let's say I've got main above and all that kind of stuff. I'm not going to write that every time. So let's say I've got this int dog heights, and this time I want the user to enter the number of dogs at the dog heights. So enter dog heights. Okay. And what they're going to do is I need to scan 3 times. So the easy way to do this is just creating a variable I and creating a for loop. Okay, because this will iterate 3 times from 0 to 2 with a step size of 1. So now I can do something like scanf %d address of dog heights I. Okay, so now what will happen is we create our dog heights. So we've got 3 spaces there. We then print to the screen enter dog heights. Then we go around this loop. So we have I as 0. Then we scan dog heights 0. So let's say the user enters a 4. Then the 4 will go into the 0. We go back up. Is 0 less? Then we add 1. Is 1 less than 3? Yes. So we go down here, scan it, dog height's 1. We put the result in, so they enter a 2. We then go up, we add 1, so we've got 2. Is 2 less than 3? Yes. So dog height 2 will be where whatever the user puts on the screen will go. Okay. And then we increment again, and we get 3, and then the loop will end because 3 is not less than 3. Okay, so this is where we can do some really good stuff with arrays and for loops. Okay, does that make sense?
Really curious why that's not working. All right, let me just check the lab. So we've got 2 big concepts next week. That's the first one. And I don't think you have to do anything too complex with that. You're given a lot of formulas. And the second question is just a bunch of for loops. All right, so that's your arrays. Now we're going to look at functions. So this is actually quite a big topic. So if you get ahead in it, it will make a huge difference. I'm going to have a quick break before that though, because this is a fairly large topic. I'm going to go through it quickly because I don't want to bore you, and I think everyone's slowly leaving anyway. But if you want to continue, do you want to continue with functions? So you're ready for next week? Or would you like to do something else or cover something else? Let me know. I'll be back in like 5 minutes. Let me know what you want to do. If you want to cover functions or if you want to cover something else. But functions is something that will come up next week. So arrays and functions, the big 2 concepts for next week. We'll be back in 5 or less. All right, welcome back. We're going to look at functions briefly. So with arrays and functions, and we'll get to pointers, these are things that we're going to be covering for the next couple of weeks. Arrays start off fairly easy and get a bit complex. Same with functions. And then we have pointers, which are fun, but they're hard to get your head around. And they're all interrelated. And what makes them confusing. So in our code so far, so let me just write, oh my God. Let me just write some code. Hash include .h. We will look at libraries as a very last thing. So this part here isn't too important so far. But we have seen functions already. So this is the first function we've seen in this subject. And this is the main function. And this is the entry point. This is a special function. But all our functions have similar syntax. So you'll notice that there's an int here, there's a name here, there's some brackets here, and there's a return. You'll notice also that there's some brackets here and brackets here. And these are the main things that make up a function. Now, we're going to make our own functions because we want to do things multiple times. So, for example, every time we call printf, we are calling a function that is stored inside standard.io.h. Okay? The reason we call printf is because, let me see if I can find it. Where's my PC? C. GW. Give me 2 seconds. Let me see if I can actually find it. Because I think it will help your understanding. Okay, so if we actually open up standard.io, we'll see something that looks like this, and it's fairly complex code. And if we go down far enough, so you can see that there's a bit of complex code going on here, and it's actually quite complex because it's actually called more functions. So by using printf, we don't have to write this out every single time. Instead, we can just call this function to do this. Okay, so similarly, we've seen in the labs with the function pow. Okay, so this is the function power. Okay, so this function works by you put your value in here and you put what it's raised to here, and it will calculate that. It means that we don't have to write the code out for this every single time we want to calculate a power. Okay, so let's say, for myself, I want to do, let me think, something simple. I want to add and multiply. I'm trying to get a better example. Okay, we'll yeah, let's do power, because that's actually a pretty good one. So we're going to write our own power function. Okay, so we're not going to use the one that's there. We're actually going to write our own. We'll start with the first one. We'll just do squared, and then we'll go to something more complex if we have time. So let me just write it and we'll go from there. So we'll go float. Yeah, let's go float. Float squared int base. Okay. Okay, so I haven't put everything in this function yet, but this is now another function. Okay, you can see it looks very similar to main. And you'll notice that it's the first thing that we've written outside of main. Yay, we've finally escaped main. Now, when we create a function, we also need to write a function prototype up here. Basically, for now, you just copy what you've written here and write it here. I'll explain what all this means in a second, but this part is something that I can explain later. So you've got your function prototype up the top, and then you've got your function below main. Okay, so this is called prototype, and this is your actual function. Okay, now you'll notice that I've got a float here, I've got the name of my function, and then I've got these brackets. Compared to main, I've actually got something inside these brackets, and then I've got my return. Okay, so this here is the input to the function, and this here is the exit. Now, the type that is returned in the function is defined here. So if I return 1.2, that's fine because it's a float. If I return a 1 here, it will be converted to a float when it's returned. Okay, we'll see what returned means in a second. So the input is what goes into the function. So up in main, let's say I want to create a variable, int w is the value of, let's say, 2 squared. So instead of writing 2 times 2 or whatever, we can call that function every time we want to square something now. So I can say squared 2. Now, the reason I can do this is because this has to be an int. Okay, so this here is the input. So this 2 is getting sent here and stored into base. Now, this gets a lot more complex, but I'm just trying to keep it simple for now because it's quite late at night. Okay, so this 2 is getting sent to the function. What is returned from this function is what is in here. So what I'm going to do in here is create a new variable, int x equals base times base, and I return x. So let's watch what happens. So I create my variable w inside my function main. There's nothing in w yet. We need to evaluate this side first. Okay? So this needs to be evaluated. So what will happen is we call this squared function. So now we're in this function and we pass this value to our squared function. So now we're not in main, we're in another function called squared. This has a variable called base, which the 2 was passed into. Okay? In here, I cannot talk about this variable w because I'm in the squared function. I can't see anything out. You will learn how to see out later using pointers. But if I try and write in this function, let's say base times w, it will say w is not declared because it's not declared inside these two braces. Okay? W is only defined in main, not inside here. I can create a new variable called w, and that's perfectly safe because inside here, w is its own variable. It's not the same w as in main. Okay? So each function has its own variables, and it can't see the variables of the other function. So if I create another w, it's going to be a different w inside squared. Now, we're in squared, so we've passed this 2 to this new variable called base, which is created. Okay, so whatever's inside there is created when we call it, and that value is passed into it. So that has 2 now. Then we create a new variable, x. So this is inside the squared function. Okay, so when we're in main, we can't talk about x because we haven't declared x in here, and they're in separate functions. Okay, and if we have 2 variables, one x in main and one in squared, they're both completely different places in memory. Okay, so one can hold 7 and one can hold 83. They're never going to touch each other because they're in separate functions. So we come here, we get our base and times it by our base. So 2 times 2 is 4, and we store it in our x. We then return our x value. So basically, this will be returned as a float. So the 4 will come back as a 4.0. And this is evaluated. So this is now evaluated. So we've now got the same thing as saying int w becomes 4.0. Now, when we return, we lose all access to these variables, so we can't talk about them anymore. Okay? They're gone. So I can't talk about x, and I can't talk about base in here at all, because they're not declared between these 2 braces. Okay? And if I do have a variable with the same name, they're not connected whatsoever. Okay? So that's that. We can also have void functions that don't return anything. So I can have, actually I'll do another example. So this is my square. And I had squared 2. I can also go int p becomes squared 3 plus squared 6. Okay. This one is going to call the function, run it, and return a value, then this one will call a function, run it, and return a value. These are only local to when it's called, okay? So when this one's called, it will create a new base variable and a new x variable, calculate everything and return a value. And then we call this, it will create a new base variable and a new x variable, calculate it and return, okay? And I'll probably go through this on the whiteboard next week as well, because it gets a bit confusing. So the other thing we can do is we can introduce void functions. So void, yeah. So this function, every time I call it, will print to the screen R. Okay? So that's the last comment I've got on the chat. So the first thing I need to do is make sure that I've got my prototype up the top. So void, yell, close brackets. Now, void means it doesn't return anything. So if it's void, it doesn't have a return statement. So I can't write something like int z becomes yell because it doesn't return anything to be stored. So like some of the functions you've seen, we just have to write yell. Okay? And every time I write this, it's going to print to the screen R. Okay? Now, let's say I want to make this a little bit more complex. I don't actually need to delete anything. I'm actually creating a new function. That's good. So below that, I'm going to create another function. Make these a little smaller as well. So actually, before I even go on, how's that sticking in your head? This is something that's going to take a while to understand, and I am skipping a lot because there's quite a lot of detail in this, but I want you to have the basic understanding. So tell me if that's making sense so far, just basically. All right. Kind of get it? Yeah. It's going to take a little bit of practice to get used to. It is a fairly large concept, and I am skipping over a fair bit just because it's a bit hard to explain everything to start off with. Because if I start off with everything, it's going to get more confused. Because how it's sent and sent back is actually a little bit more confusing than how I'm showing. So what I might look at instead, so I might leave this here. I think you've got the basic concept. What I'm going to look at instead is scope, because I think that's probably a little bit easier and may help the understanding of functions slightly. May make functions a bit easier. So in our function, in our program so far, we haven't looked at scope very much. But it is an important concept. So I'm going to create a variable x, and then I'm going to go if x equals 4, then int z becomes 3. And what I'm going to do after this is printf empty z. Then what I'm going to do is to printf empty z. Now, from what you've done so far, you're likely to look at this and go, yeah, this should compile. However, it won't. It will say line X, Z is undeclared. Okay, it will say Z is undeclared. Okay, so this is where scope comes in. So everything between these braces and these braces that is defined in only these braces are in scope everything below and in. Okay? Everything inside these braces is everything below that variable where it's defined and in. So Z is only defined between these two braces. As soon as we leave this if statement, Z is gone. Okay? Z is not a variable in our function anymore, in our program anymore, because it is only local between these two braces. Okay? So we can't do something like this. Another thing that you need to be careful of is we can redeclare Z. We're not actually redeclaring it because it was never in scope, but we create another Z and we print this. Now, you may expect this to print 3, but it won't. So let's go through what happens here. So let's go line by line to explain scope. So we're on this line, we create our X variable. We create our X variable and we initialize it to 4. We then check is X equal to 4? Yes, that's obvious. So we're on that line. We then come in here and we create our Z variable. Z variable has 3 in it. Beautiful. Then we come here and we print to the screen 3. We then leave this scope. So we leave these braces. And Z, because it was defined within these braces, is now undefined. We then create another Z. And this one's uninitialized. Okay? We haven't put any values in it. It is not the same Z as this Z. Okay? And this is another reason why you should give things meaningful names, because this is a horrible example, because it is really confusing and you shouldn't really do things like this because it would be confusing, but it explains scope. So we now have another Z which will print some random value. Okay? Going further than this, we can actually get rid of the if statement completely. So these braces that define scope don't need to be used with a loop or an if statement. They can actually just be used by themselves. So this one has the same problem. Okay? We can define scope wherever we like using these braces. We can put these braces anywhere in our code without an if statement or a while statement to limit the scope of a variable between them. So when it ends these braces, it's gone. For a lot of our code, we've been putting all our variables at the top, meaning that if we go into some braces, it doesn't matter because it's defined down and in, down and in. Okay? So it means that if they're right at the top, it's pretty much can get into everywhere and it's defined. However, as we go into functions and as we get to more efficient programming, we're going to start wanting to limit scope. So for example, let's say I'm doing a massive calculation here and I need 50,000 variables, okay? Which isn't very many when you start looking at arrays. I don't want to carry around these 50,000 variables and waste memory throughout my program. So I limit their scope between these two braces such that they're only declared while I'm doing this massive calculation. And then once I leave that, they're gone. As we saw before with the functions, the scope is in the function as well. So if we leave our function, every variable that's in here is not in here. Does that make sense? Yes, cool. Cool. All right. So if you understand this, it'll help a lot in how you do functions. And because the scope thing is very confusing. And when we get to pointers, you'll just want to rip your hair out because it gets even more confusing. But the fact that there's this line between here and here means that if I have a W in this function, it's a completely different W than what is in main. So if I change this one to a 3, this one stays a 1. If I change this to a 5, it stays a 1. If I change it to a 6, it stays a 1. Once the function's over, it's gone. Okay? Every time I call a function, these variables are recreated, so they won't hold their value. There is things you can do so that they do hold their value, which you'll see in next week's lecture, hopefully. But I'm not going to show you that now because you won't need that for next week's lab. Let me just have a look at next week's lab. Just see what else you need to know. Blah, blah, blah. I love trying this one. So you've got arrays, simple arrays, that's fine. And then you've got functions. Q. All right. And then some for loops. All right. All right. I think we might as well finish there. I will do an intro to functions in the lab because I think that it is a concept that people will struggle with. But I am starting to feel really tired, so I might just finish there. I'm going to start falling asleep otherwise. Hopefully that's not too big of a problem. But I hope that's interesting. Is a lab running tomorrow? Yes, there's 2 labs running tomorrow. They're the busy labs, the most people. So if you're not in their labs, yeah, it's gonna be hard to get help. If you want to pop into any labs, Tuesday afternoon is always the best one because there's only like 10 people. But yeah, tomorrow's the 2 most busy labs. So if you're not in them, yeah. Had problems with what code? Are you in the lab tomorrow? The assignment. We're not looking at people's assignments. You can ask your questions about the assignments. We'll look at errors. The final value. Okay, so the final value probably has to do with the fact that it's less than or equals. You are using a for loop, I hope. And if you are, the reason generally that you won't get the last one is because you're doing less than rather than less than or equals, or greater than rather than greater than or equals. Because if it's inclusive, then it includes the equals, so the last value. Where if it's exclusive, then it wouldn't include that value. Does that make sense? So, for example, if I have 4 I equals 0, I less than 3, I plus plus, and I print out I each time, then I get 0, 1, 2. If I do I less than or equals, I get 0, 1, 2, 3. Okay. If you have problems with the assignment, you can put the questions on the forum and we'll answer them, but we're not directly debugging anybody's code. Okay. So if you've got a question, you're welcome to answer it, like that kind of question. But we're not looking at code because it's unfair. We will look at errors though. If there's some error message that you've never seen before, that's fine. Or warning message you've never seen before, we may help you. But the actual code itself, we're not looking at. All right. Have a good night and enjoy, and hopefully that was very helpful.